All right, so this is our fourth structures meeting. On the agenda today, we have pretty much going over how to use ClickUp, going over the FinCAN designs and hopefully discussing any more options that we have for them. And then talking about the wind that we did last Saturday. And how we're planning on removing the airframe from the mandrel. So I will go more into ClickUp at the end, but this is just more of an introduction right here. I don't know, I know that all of you weren't able to make it to the Tuesday meeting, the general meeting. Those are at 7 p.m. in case y'all were not sure on Tuesdays. Pretty much it's our new organization tool, just a calendar to keep us on track, have deadlines, have start dates, just so we're not kind of just out on our own figuring it out. We'll actually have some basis as to what we can be working on. And then that way y'all will also have access to it. So you don't have to necessarily reach out to me and ask what's coming up next. You can always look on here and know what to be expecting. All right, so these we should all be pretty familiar with. Donald, I know this is your first meeting with us, so I will go over these designs. So for this one, we essentially have 4 separate plates, or not plates, but 4 separate sections. They would each be slotted to have the fin go into it. And then that fin would be screwed in and the sections would be screwed into each other. We're trying to do this externally because we're going for a minimum diameter rocket, meaning that the entire diameter of the inside, which is like, I guess we're going for 4 inches, that is going to be just motor. So there's not going to be any wiggle room to secure our fins on the inside. So we're going for something external, which is something we haven't had to do before. So we're playing around with new ideas.
Okay.
This is the first one we have going on. The second one is this bad boy, which is I mean, similar concept, except on this one, we would have the 4 fins, which would be the top left right here. And then we would have something that pretty much slots over it. Can I help you? Come here.
Can you show the dog?
Irvin, I've shown the dogs twice just because you joined late. I'll show them at the end. If they behave.
Okay.
So we have this little thing that's gonna slot over them. Neither of them are foolproof. We still have to do some problem solving, figure out how to secure it, because obviously if it's just a, you know, a cylinder on a cylinder, it's just going to slide up and down. So we are trying to figure out how to deal with something besides like a friction fit. Trying to figure out secure it above, below. Will we be able to put like a notch inside, do a ring to keep it all secured, do like little indentations around the, like on the outside of the airframe. Just playing around with different ideas. I think what we're trying to do is come up with more designs than just these 2. Just so we know that we've considered all of our options and that we're not just limiting ourselves to these. But these are the main 2 that we have going on right now. I think we are trying to decide on a design within the next week or 2. So like next meeting or the meeting after next, we're gonna have we're gonna have all the designs that we have in consideration, and we're gonna try to decide on which one to go with. So that is that recap. You can ask any questions at the end of it. I'll just get through the rest of the presentation.
Okay.
So here's what we did on Saturday. Here's our cute little time lapse. Pretty much we'll be doing a documentation over how to operate the X-Winder, just so anyone can do it. The X-Winder pretty much takes a toe of some material. For us, it was fiberglass. it is dipped in epoxy, wrapped around this aluminum rod that you see, which is what we call our mandrel. And then it's like, for the time being, the way that we harden it is by covering it in heat shrink tape and putting a heat gun on it. At least that's what we did on Saturday. So this is something that we're going to be getting a lot more familiar with as the semester goes on. We might even consider trying to like look into I don't know, different materials or just different widths of the mandrel. So what we winded on Saturday was a 2-inch. It would be nice if we could get up to doing 4-inch at some point, but due to time constraints, we went with the 2-inch on Saturday. I don't know when our next wind will be yet, but we do need to start thinking about removal processes. So the issue we're running into right now is that the airframe does not just slide off the mandrel. It takes well, I guess the first time that they tried to take it off, they only got half of it off, and then instead just decided to cut off the half they pulled off, and then cut a line down the middle of the second piece and just pulled it off, which means of course it's not usable. And then for the second attempt, we did pretty much the same method, except this time we were like, screw it, we're gonna strap this bad boy to a car. So it was a bit of a tug of war between a pole and a car and a parking garage. It came off, it did in fact work, but there's of course some concerns there, and we'd like to probably find a more professional method to go with it. If we end up deciding to just say screw it and stick with the car method for now, that's fine, but we just need to eventually be thinking about how can we be more efficient and more professional in the process of everything. And now we have discussion time. So ask any questions you have now while I get ClickUp open over here. So Donald, if you have any questions, if anyone else has any ideas, I know Eason, you also had your idea for how to get the airframe off the mandrel.
Yeah, so I think we could reduce like the amount of friction between the wind or whatever and the mandrel by using dry ice inside the mandrel. You would just like you would cap off like both ends with like, I don't know, just an old t-shirt or something, like stuff it in there, and you put dry ice to where it's like right where the wind is on the mandrel, and you just let the mandrel cool down because it's aluminum, and it should shrink faster than the wind does, because the wind is epoxy and fiberglass.
Do you think do you think that would have any effect on the durability of the wind itself? Like, would that like ruin it at all?
I don't think so, because I don't think the temperature of the epoxy would drop very much, because the dry ice is on the inside and the epoxy and fiberglass is on the outside, and it doesn't conduct heat very well. So I don't think that's going to be an issue. And we're not going to like leave it overnight. We're just going to do it for like, I don't know, an hour or something at most, and then pull it off, or try to pull it off quickly. We might be able to do it by hand. I'm not sure.
Yeah, I can definitely look into where you can buy dry ice from, and look into, you know, how effective it is on aluminum. So that is something I can jot down.
Also, after recovering Oberon last whatever month it was, June or this June, I think. The airframe was pretty hot, and I think since the rocket this time is going to be like, you know, mostly motor, there's going to be more heat transfer from the motor to the airframe, and you know the airframe's partly epoxy, so the heat could weaken the epoxy. So I'm thinking like a thin layer of some kind of insulation between the motor and airframe might be a good idea. My only idea right now is like some kind of aluminum foil or tape on the like inside of the airframe, but you know I'm sure there's other stuff we can use.
Yeah, it's definitely something that we can add to some of our brainstorming ideas. Does anyone have any ideas when it comes to modular fin canisters?
So
Hello, Pete. Oh, sorry. Go ahead.
no, you go ahead.
No, mine wasn't too related, but go ahead.
Oh, okay. Well, so I kind of like that second option with the fins with the cover.
The sleeve?
And yeah, the sleeve. And so what if there was like a notch that stuck out on the airframe with like grooves in like the fin piece that you could slide it down onto and then twist it and it would like lock in like mechanically. That's what I was like kind of thinking, just like at first thought that would probably be significantly better than a friction fit, and you'd have that piece of plastic or whatever material that we're using for the sleeve and stuff would also be locked on into place as well.
So you just want to put like grooves in the exterior of the airframe because it can't go
In the
too far.
Yeah, in the
inward.
exterior, or have like a notch that sticks out on the well, yeah, I guess it would have to be in the airframe itself, but then you would like twist it and it would lock into place because there wouldn't be anywhere for it to move vertically.
I know that something that we were kind of considering is like putting things on the outside. I think Gustavo was trying to have an idea about like putting a notch at like the top to keep it from sliding up. You're talking about like putting something to like slot it into it. I think it was Ali was talking about a ring exterior to like grip onto. So it seems like we got a lot of that's where a lot of people are leaning towards is an idea of trying to
Yeah, I was about to ask if you guys, came up with any solution about that, since I wasn't able to join last meeting, so I wasn't sure. But wasn't the didn't what's his name? What he liked the clamp idea? Wasn't he suggesting doing something with the clamp, or is that out of the table?
Yeah, well the clamp is still an option, but the clamp itself would just be a friction fit. And I guess what we're looking for is something that we can justify more, that it would be more durable than just friction. Because
Sorry, as well as the what is he still like trying to do the one with the bolt and a glue, like he showed us last time?
yeah, I know that that's one of the things we were talking about. I know one of the ideas that I quite liked was finding a way to screw it onto something at the bottom. So like one thing to like clamp in the motor and then like another thing to screw onto the fin canister, something that I would like to see. I know we all have any design that we choose, we'll have to figure out what idea is going to work best for us. So I think when we get to that point, what I'm going to try and do is it doesn't have to be like super complicated, but I would like to see everyone just come up with like a rough idea of what they would like to see or what they would think to implement. And don't think it has to be anything crazy or that you have to solve the problem completely by yourself. It just has to be an idea. So one thing that I would really like to see for let's see. We'll do meeting after next, since yeah, we'll do meeting after next. So that gives you 2 weeks to come up with an idea. It can be one that you've already mentioned. It can be elaborating on something else that you've already heard. Just something to where you think we can take these 2 designs or a new design of your own. I would also love to see that. Where you think you could make these more dependable than just a friction fit. You can secure it from the top, you can secure it from the bottom, you can, but the one thing that it really can't be is we can't penetrate into the airframe. Maybe above, but that would still, no, the motor would go too far into the rocket. So mostly try and focus on exterior ways of doing that, either by adding little nooks in the airframe itself, or like adding them ourselves, adding something at the bottom, on top, just an idea. I would quite like to see that.
Wasn't there like a space like above where we were gonna connect like the motor to? Like, I remember at the last meeting, like Gus was talking about having like some aluminum piece like in the airframe and then connecting it to like bolting it to the motor, so it's like stays there when it's like running. So
Yeah.
like there'd be like still like there'd be like a space between there. You could like maybe like project Joe into that part or no?
So the only problem with that is the motor is gonna end far higher than where our canister is gonna be. So like for like reference, we're gonna have our fins like down here, and like the motor is gonna end like like somewhere all the way like up above that point. I mean, granted, it would also kind of be a discussion with analysis and everything. I don't think we've committed to the fins having to be at the bottom. So if we went a route different from that, we can definitely talk with the rest of the teams and talk about the positioning of the fins. If we did want to go down that road.
Hey, also something I was thinking about too is that some of the motors usually have rings already, or like sections at the bottom that prevents anything that slides to keep sliding downwards. I don't know if you remember, but the Loki M3000 had this like ring type of thing that came out of it, and that's what we used to secure the MMM, so it wouldn't slide all the way down. So depending on what motor we get, it might be able to have a design that could like facilitate the modular fin can. So honestly, now that I'm thinking about it too, maybe you should contact Propulsion, and maybe Propulsion should figure out what motors are best for us earlier. That way y'all can have an idea as to ways that our motor, like the motor we choose, could end up helping structures.
Okay.
Like, I don't know if you also seen that Cicerone, I think it's like I forgot the name of the Cicerone. At the lab, it's like a smaller, like 3-grain motor. At the very bottom, it has like a little section where we slide some cardboard tube, and like it prevents it from sliding all the way down. I'll send a picture if I could go to the lab and like show you how it looks, because that could potentially help like fix a lot of the issues, since it's I guess a 4-inch diameter airframe.
Yeah. And then I'll also go ahead and reach out. Yeah, so I'll message Tala and discuss some of that stuff with her. And
Also, is
then,
it,
go ahead.
I was gonna ask, like, is the shape of the fence also like determined already or no? Okay, just
It's
asking.
all on us. Yeah, we'll just be doing it step by step, and that's mostly what this bad boy over here is for. Our finished design and everything is a couple months into the semester. Everything that we're doing right now is more so just our design ideas. And I think when I was mentioning everything that we had to do, Gustavo said that I think like fins are the last thing that we have to do because it's gonna be based off of like weight and all this other stuff that we have to do. So that is something that'll be one of the last things we tackle.
Yeah, I was just asking because like depending on like the shape of the fins, like it could connect like how you have like the slots and stuff for if you're going to do the slide sleeve idea, it could be like different. That's why I was just asking.
Oh, gotcha. Yeah, honestly, anything that we decide on isn't permanent. It's all gonna be an idea and then taking that idea and figuring out, okay, where do we go from here? Does that change our original idea and just modify things from there? So yeah, nothing's set in stone. Just because we decide a design, that doesn't mean that we might not have to adjust it or modify it in any way. There are a whopping 10 minutes left in this meeting. So I think what I'm gonna do is end this meeting here where we have most of our content stuff. And then on the next meeting, we'll tackle just finishing off and getting a framework going for on ClickUp, and then we can call it after that. Does that work for y'all?
Yep.
All right, I will stop this recording.